The following content has been generated with artificial intelligence under minimal human supervision. The data presented may contain errors or inaccuracies. The opinions expressed in this content do not necessarily reflect the vision, position, or values of DigiAll. We recommend verifying critical information with additional sources before making decisions based on this content.
Welcome to DigiAll Tech News. Today is Thursday, July 23rd, 2026. I'm Kylie Brooks, and this is where technology becomes clear and engaging. A new Silicon Valley startup group is urging the Trump administration not to block US access to Chinese open-weight AI models. Alphabet and Tesla beat revenue expectations, but Wall Street is focusing on negative free cash flow and soaring AI-related capital spending. NVIDIA has commissioned a DGX GB300 supercomputer for military education and applied AI research at the Naval Postgraduate School. Stanford HAI is using AI to scan 500 million words of state law for decades of regulatory sludge. Radiology is showing the more realistic future of medical AI, not full replacement, but a major redesign of daily clinical work. Let's start with a fight over who gets to build with which AI tools. The newly formed Little Tech Association, representing nearly 200 Silicon Valley startups including Proton and Y Combinator, sent letters on July 22nd to President Donald Trump, Commerce Secretary Howard Lutnick, OSTP, Director Michael Kratsios, and other officials. The group is asking the administration not to impose broad restrictions on US access to Chinese open-weight models from companies such as Moonshot AI and Alibaba. Their argument is not that security concerns disappear, it is that American leadership depends on both world-class US open-weight models and continued access for builders to models already available globally. That matters because small companies often use open models to test ideas and control costs before they can afford expensive hosted APIs. Particle founder Suhail Doshi warned that a blanket ban could instantly kill hundreds of companies and push business toward larger US labs like Anthropic. On the other side, administration officials have raised allegations around model distillation, IP theft, and banned NVIDIA GB300 servers tied to Moonshot. But as of July 22nd, Commerce had not drafted entity list additions or a formal ban. So the real policy question is whether Washington can use the scalpel Little Tech is asking for, instead of a sledgehammer that treats startup access and national security as if only one can survive. Now this is where the AI boom gets very concrete. The bill is arriving before the full payoff. Alphabet and Tesla opened tech earnings season with better than expected revenue, but both reported negative free cash flow. Tesla posted a $1.1 billion deficit, compared with positive $146 million a year earlier. Alphabet was negative $5.9 billion, after being nearly $25 billion positive a year before. Investors reacted quickly, with Alphabet down more than 3%, and Tesla down more than 4% in after-hours trading. The pressure is capital expenditure. Alphabet raised its full-year guidance to $195 to $205 billion, up from $180 to $190 billion, and warned that 2027 spending could be higher. Tesla still expects more than $25 billion in capex this year, with second quarter capex up 142% to $5.79 billion. Most of Alphabet's $44.9 billion in second quarter capex went to AI infrastructure. Tesla is spending towards Cybercab production, Optimus robots, and a new Texas AI chip plant. In practical terms, these companies are asking investors to believe that infrastructure built today will become products, margins, and defensible advantage later. The harder part is that cheaper open-source Chinese models and more cautious corporate spending on AI services make the return on investment question much sharper. Here's the key context on NVIDIA's military education push. This is not just about putting a powerful machine in a room. Jensen Huang visited the Naval Postgraduate School in Monterey, California, to commission an NVIDIA DGX GB300 supercomputer with mission control software. The system brings on-premises large-scale AI computing to more than 1,500 in-resident students and 600 faculty, including model training, inference, foundation model work, and high-fidelity simulations. The applications named are very practical: weather prediction, cybersecurity, disaster resilience, and response planning. It also builds on an existing NVIDIA AI Technology Center on campus, adds Deep Learning Institute toolkits for faculty, and connects with work alongside MIT RE, using Omniverse for digital twin environments around navigation and decision-making. The bigger issue is education. If military officers, engineers, and researchers can train and test AI systems directly, they can ask more operationally relevant questions than they could from a slide deck. But the responsibility scales with the compute. When AI tools move closer to planning and decision support, the curriculum has to teach judgment, consequences, and failure modes alongside speed. There is also a quieter, less glamorous AI story in government, and it may be one of the most useful. Stanford HAI reports an AI tool built to analyze 500 million words of state statutes across all 50 US states, looking for common patterns in regulatory sludge, old, overlapping, or redundant rules that build up over decades. For businesses and citizens, that kind of accumulation can mean slower permits, repeated paperwork, and compliance costs that no one designed as a single system, but everyone has to navigate. The promise is that AI can turn an impossible manual audit into a map, helping states spot where modernization might reduce friction without removing core protections. The trade-off is important though. A paragraph that looks redundant to a model may still protect safety, rights, competition, or accountability in a specific context. So the strongest version of this is not AI as an automatic rule cutter, it is AI as a searchlight. It shows policymakers where to look, while humans still decide what should change. Let's end with radiology, because it is a useful correction to one of tech's favorite habits, declaring the job market solved before the work actually changes. In 2016, Geoffrey Hinton predicted that computers would replace radiologists as medical image readers within 5 years. By July 2026, that has not happened. Radiology is still the leading medical specialty for AI adoption, with roughly 3/4 of the 1,400 AI-enabled medical devices cleared by the FDA belonging to the field. At the same time, workforce projections still point to growth of 26% or more over the next 3 decades. What has changed is the workflow. AI tools draft reports, flag urgent cases, detect polyps more effectively during colonoscopies, and sometimes identify subtle abnormalities invisible to the human eye. But radiologists still have to evaluate the output on every case and override the algorithm when it is wrong, which is harder when black box neural networks do not explain their reasoning. Experts including Curtis Langlotz, Paul Yee, Nina Kotler, and Charles Kahn describe the mental rewiring this requires, avoiding automation bias, where the machine is trusted too much, and automation complacency, where rare errors slip through. The training gap is real too. A 2026 AMA survey found that more than 1/4 of physicians received no AI training, and only 11% received substantial training. So the lesson is not that AI replaces radiologists. It is that radiologists who learn to work well with AI are likely to outpace those who do not. Today's through line is that AI is moving from demos into power structures. Who can access models, who can afford infrastructure, how institutions teach with advanced compute, how governments review their own rules, and how professionals share judgment with machines. The next test is not just what these systems can do, but how carefully people choose to use them. Thank you for staying informed with DigiAll Tech News. We'll be back with more updates as they develop.